this is FRQ 357. We're gonna do probably a net change, and let's see. It asks about a minimum down here, so that looks like absolute minimum. It's just got a bunch of questions based on this. Now, let's read this question carefully. People enter a line for an escalator at a rate given by this rate. Okay, now notice this number 1, it's piecewise. From 0 to 300, it's the top equation, and after 300, there's no one, I guess, is getting on. RT is a measure in people per second, so remember that unit, and T is measured in seconds. As people get on the escalator, they exit at a constant rate of 0.7 persons per second. So this is how they enter, and there's how they exit. And there are 20 people in line, so we have initial condition when T equals 0, we have 20 people. So we have all that information. Now, the first thing is how many people enter the line during the time 0 to 300. So that's a simple integration, how many people enter it. So we don't need to worry about change or anything like that or original amount. So number of people who enter would be equal to integral of 0 to 300 of, I'm going to put the numbers because it's a piecewise, and since I don't want to have to show the choice, I'm just going to put which one I picked because it obviously would be the top one. T over 100 cubed, by the way, this is calculator active, thank goodness, right? 1 minus T over 300 to the 7th power. dt, and if you put that into your calculator, you get 270 people. Okay, part B, I'll do the points all at the end. People in line at T equals 300. How many people in line? All right, now we have to include everything. Who was there at the beginning? Who came on and who came off? So people in line at T equals 300 would be, right, 20, or T of, I don't know what we should say because we don't really have a function, I guess. We'll say R of, that's a rate. So I don't have like a function for the position or the original function, so like X or whatever, so I'm just going to use the 20 plus then the change, people coming on 0 to 300, and we already know that's 270, but we're going to write it the right way, right? Show what you know. Don't put 270 here. Show that you know you had to take that integral, and then we have to take off the integral of 0.7 dt. That's the number of people who leave. And so that is going to equal 20 plus 270 minus 0.7t from 0 to 300. Okay, this is the 0.7t to 300. So it's 290 minus, and you can do this one without a calculator, 80, sorry, that was my answer, minus 210 is equal to 80 people. So that was fairly easy. Hopefully you got that one correct. Part C says for T greater than 300, what's the first time there are no people in line for the escalator? Okay, that means that it's you had to start with 20, take away, how many people are there at 300? So we know there's 80 people, and then then they're going to continue, right, to leave, and that's that 0.7t. So when will that be equal to 0, right? So we would just say 80 minus 0.7t, because that's how many people there at t equals 300, and then people leaving, and set that equal to 0. And so you get t equals This is time 114.286. Now that's after 300 seconds, so you have to add that. So you would get a total, adding that to 300, you would get a total of 414.286 seconds. That's when when there were no more people in line for the escalator. All right, so that was that answer. And then D says, okay, if you're between 0 and 300, at what time is the number of people in the line a minimum? To the nearest whole number, find the number of people in line. So when is it a minimum, and what is the number of people that's the minimum? Like, how many are there? So at time what, and how many people were there? So, and justify your answer. So this is like a way to say what was the absolute minimum. So we've got to look at our endpoints and then the critical points in between. And the critical points is not clear cut because we have two functions. So we would start with at t equals 0, t of 0, we have 20 people. And at t of 300, we know we have 80 people. Okay, so we know the 0 and 300, the endpoints. So now we have to figure out the total number of people at any time, and then we would take the derivative of that and set it equals 0, right? Because you know to get the minimum, you have to take the derivative, set it equal to 0 to find your critical points. So our function of the people, total number of people at time t, any time t, is 20. Let's just put people at time t is 20 plus the interval from 0 to t, and let's just use r of x dx because we can't use t, minus 0.7t, right? That's the coming off. And we write r of x because that's like a really complicated thing, and since we can use our calculator, we can just do that. Now, look, if we take the derivative of that, d dx, d dt, not d dx, d dt of 20 plus the integral of 0 to t of r of x dx minus 0.7t, you get 0 plus r of t minus 0.7. So taking the derivative piece by piece, the derivative of 20, the derivative of an integral is just the integral at that point. I mean, just the original function at that. So the t goes down there in the x. And then taking the derivative of 0.7t is 0.7. So now we would set that equal to 0. So we would say, when is r of t? So r of t would equal 0.7. And we would use this function in your calculator, and I used the solve, and I solved for r of t equal to 0.7, so make sure you can use solve on your calculator. And I got x equals 33.01328. Remember, go out further because you are going to need those numbers. And then x equals 166.57472. Now those are the times that you would have, so you're going to add, so then you would have to find r of 33.013298. So how do you figure that out? How many people are at that time? It's not r of, actually, it's the whole thing. So back out. We would use 20 plus 0, this should be t, to 33.013298, right, of r of t dt minus 0.7 times 33.013298, and you get 4. It's like 3.8 or something, so 3.8 or 4. So I'm kind of running out of room, but at t of 33.013, just say that it's about 4 people. And if you do the same thing, t of 166.574 is approximately equal to, how many people did I get? 158 people. So the time is 33.013, and it's 4 people, the time when it's at a minimum. So you would write that up nicely. And you can see on my handout, I just wrote as time t equals 33.103 seconds, they're the least number of people in lines, 4 people. Okay, so how do we get points for this one? First of all, you get a point for the first thing. This integral is +1 and +1 for the answer. So 2 points for part A. You get 2 points for part B. Part B, you get a point for considers the rate out. So you get +1 for this, and you get 1 for the answer of 80 people. So that was 2. For part C, it's worth 1 point. So just the answer would be 414.286. So I'm just going to rewrite this so you don't get confused. This is 1 point. This is only worth 1. And D is worth 4 points. Okay? First point is considers R of T minus 0.7. This right here, you have that somewhere? Because you need it. You get 1. Identifies 33.013 somewhere, you get another point. Answer, that is 4 people at that, get you another point. And the explanation, which would be your chart, this chart carried on, would be your other point. So I'll put it up here. So that was 4 points for that. So that's FRQ 357.